Today I'm gonna write a pairs trading strategy, which is the basic strategy that Edward Thorpe used to make his 800 million fortune. I've been obsessed with this strategy ever since I read his book called A Man for All Markets a few years ago, and realizing that not only this guy beat the casino by inventing card counting, but he also beat the stock market with this strategy. Not only his fund was profitable almost every single month, but his worst monthly loss was less than 1%. It's a market neutral strategy, which means potentially we can make money whether if the price is in an uptrend, a downtrend, or even in a range. I'm gonna show it on a chart in a second, but then I will also show the basic math behind it in a Jupyter notebook, and then we will write it inside Jesse so we can run some backtests and see some actual results. So if that sounds interesting, let's get right into it. Alright, let's begin with a very simple example. Ethereum versus Ethereum Classic. They have different price ranges. Ethereum is in matter of thousands of dollars, but Ethereum Classic is, I think, in hundreds. But we know their prices are highly correlated, and that's really what we care about. So for example, on this chart, I have both their prices, and I've set it to be on the same price scale just so that we can see them easier. And we can see, for example, in here, the price of Ethereum is actually lower than the price of Ethereum Classic, but it becomes the opposite in here. The price of Ethereum is actually more than the price of Ethereum Classic. So what does it mean? It means that if we open a long position for Ethereum at this point in time, and at the same time open a short position for Ethereum Classic here, and hold that position, when we reach this point in time, you can see that it's the opposite now. The price of Ethereum Classic is lower than the price of Ethereum. So what does it mean? It means that yes, both their prices are lower than what it was at this point in time. But if we opened two opposite side positions, one long and the other one short, at this point we would have made money. Why? Because our short position would have made more money than the amount that our long position lost. So the difference between the P&L of both positions would be our profit. Now, if I go back in time, you can find so many positions where this opportunity existed. I'm going to explain the math behind this strategy in a second with some code, but I want to mention that this video right here by Contopian is where I initially learned about the math behind it, and in my video I won't go through as much detail as they did, so definitely check out their video if you want to learn about this topic in more details. Alright, so first I'm going to show you the basics of pairs trading in a Jupyter Notebooks, which is great for a presentation. And in case you didn't know, if you want to use Jupyter Notebooks with Jesse, all you need to do is to make sure they are inside your Jesse project. Right, so my project is named Bot. I have multiple Jupyter Notebooks, and this one is the one I'm going to use. All right, so first we need to select the kernel, and I'm going to select one which already has Jesse installed in it. All right, let's add a code block, and first I'm going to import all the necessary packages. So I'm gonna say from Jesse import utils and the research module. Now the utils will give us some utility functions, and the research module is used for importing data from the database or even running backtests, but I'm not going to use that in Jupyter Notebooks in this video, but you can if you like to. All right, so next I'm going to import Jesse helpers as JH, which will give me some helpers that aren't really used in most of the strategies, but I'm going to use it in here. Next, I will import NumPy as MP. From datetime, I'm going to import datetime. And lastly, I'm going to import the matplotlib library because I'm going to show you some charts. All right, next, I want to import some data, and I'm going to use the research module's getCandles function. And first, it will ask me the name of the exchange. All right, so let's define the exchange variable here. I'm going to use Binance Perpetual Futures. And here I will pass the exchange. The second one is the symbol, and I want to use ETH and ETC, which is Ethereum Classic. All right, so the first one is going to be ETH USDT, and the time frame I want it to be 15 minutes. And then we have the start. Now the start date that is accepted here has to be in timestamp format. And to convert that, I'm going to use a helper function from Jesse. So I'm going to say this, start date equals, and I'm going to use date to timestamp. And in it, I will pass the date since 2024. The month could be the 10th month, and since the first day. And for my finish date, I'm gonna give it again date to timestamp, again 2024, 10th month, and the 3rd day. So I only want data for 2 days basically. All right, so now I have the start date, right, and the finish date. All right, so, and I can leave the other ones. All right, now this function will return 2 values, the warm-up candles and the actual candles that I want. And because I don't intend to run backtests with it in this Jupyter notebook, I don't care about the value for the warm-up candles, right? So I don't want the first one, and that's why I'm using this underline value here. But the second one, I will call it C1 or candle 1, and there we go. Now for the second one, we're gonna do the same thing, right? Except instead of ETH, we want it to be ETC. All right, let's run this and it's all good. Now next, because I want to show you a chart of these values, I'm gonna need timestamps. So I'm gonna create an empty list called times, and I'm going to loop through the first set of candles, right? And in it, I will simply say times dot pinned and date time dot from timestamp, and then I will pass the timestamp of each candle, and that will be the first index. But because this function expects the timestamps to be in seconds, but Jesse's timestamps are in milliseconds, I'm gonna have to divide this by 1000. All right, there's one more thing I need to do. Just like this chart that I just showed you, which both prices were on the same price scale, because they weren't absolute values of prices, they were price changes in matter of percentage, right? So we need to do the same in our Python code. So I'm gonna say C1 equals utils.prices to returns. And this is an already built-in function in Jesse, so I don't have to define it from scratch, which is really nice. So in it, I'm gonna have to pass all the candles, but I only want the closing prices, and that would be C1, and I'm going to select all the candles, but then I'm going to select only the closing candles, and that would be the index of 2. So in case you didn't know, the 0 index in Jesse is timestamp, and then we have the open, close, high, low, and then volume. So the close would have an index of 2. And then I'm going to do the same thing for the second price data, or Ethereum Classic, all right? And we should also change this. All right, now we can run this one. Okay, we're getting an error. All right, this shouldn't have been there, it should have been inside here. All right, so now we can finally plot the actual price data. And for that, I'm gonna say plt.figure, which is used to set the size of the chart. And in it, I'm gonna say fixed size equals 15 by 6. Now this size doesn't really matter much, it's just for presentation. You can set whatever value you like. Next, I'm gonna say plt.plot, and I'm gonna pass the timestamps and then the actual price data. And for color, I'm gonna say blue, and the label is going to be ETH. Next, I will do the same thing for Ethereum Classic, and I'm gonna set the color as red, and this should be ETC. And finally, I can do plt.legend to show me everything. All right, so now we can see the price data for both the assets on the same chart, which is really cool. Now, if you pay close attention, you can see that our theory very much sounds right. In here, for example, the price of ETH was lower than ETC, but in here it was higher than that. So in other words, if we opened a long position here and shorted the price of ETC and did the opposite in here, we would have made money. And the same goes for so many other places. It goes here, it goes here, here, here. So it just continues, right? Which is very promising. All right, so now that we have both of them on the same chart, we should begin writing the actual code based on math that we can actually use to trade it, right? Because we're not gonna have the chart when we are trading this with a bot. Right now, we're looking at this chart with our eyes. That's how we know this is happening. So we need to use statistics to come up with a good strategy. So the first step is that we need the spread. In other words, we need the difference between the two price data. So I'm gonna define a spread as C1, and then I'm gonna select since the first candle up until the end. And the reason I'm doing this is how we defined this C1 variable. We defined it in here. We converted the candles into returns. And when we did that, the first data actually became a non-value, and that's why I'm doing this. And if you don't believe me, I can print this data so you can see it. So let's print the first value, and you see it is none, right? And we cannot really have that in our strategy, so that's why I'm going to select since the first data, and when I say first, I mean the index of 1, because the actual first value would have the index of 0. So we're gonna select this one until the end, minus C2, and again selecting since the first index up until the end, right? So this is going to be our spread, which is the difference between the two price data. Now, to actually take advantage of this data, having the spread alone isn't enough. We need the z-score of it. Now, what is z-score? The z-score is the price difference, or the spread that we just defined, compared to the mean of the price data. And that's what we really care about. So we're going to define the z-score. Now, Jesse already has a utility function which will calculate the z-score for me. So I'm going to use that one. It's called z-score, and it takes the series data, or in this case, it would be our spread. Now, I'm going to also define the mean. Now, by the way, the z-score function, it will use the mean itself. Now, if you're curious to know how it works, it's basically this price series minus the mean of that price series divided by its standard deviation. Right? Now, you don't have to know about the exact math behind it. You could just use it, but knowing it certainly helps. Right, so I am also going to define the mean of it myself because I want to print it on the chart. And for that, we can use NumPy, and we will just pass the z-score, and now we can plot them, right? So first, I'm going to say plt figure, and then pass the fixed size, just like before, 15 and 6. Next, I'm gonna say plt.plot, and I'm going to pass the times, again selecting since the index of 1 to skip that nan value. And then I'm gonna pass the z-score. I'm gonna set the color to blue, and the label could also be z-score. Next, we're gonna plot a horizontal line using this syntax, and I'm gonna pass the mean that we just defined here. I'm gonna use the color black and set the line style to dash, and the label is going to be mean. And then I'll do it 2 more times for the values of 1.2 and minus 1.2 with colors of red and green. All right, so let's see how this looks like. And there we go. So now we have the z-score of the two price series, and we can see how their correlation or the related price is actually moving. So for example, in here, we can long the first asset and short the other one. And when it reaches the mean, we will just close the positions. And we can do the opposite. When the z-score goes above this line, we can short the first asset and long the second one. And again, when it reaches the mean, we can just close it, right? And as you can see, we had opportunities for this type of trade in more than once. We had it here, we had it here, 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 and so much more, right? So it looks very promising. But here's the thing though. Right now, we have this data on a beautiful chart, which is only showing us the price data for 2 days. But in reality, we're not going to have charts. We're going to trade this with a bot, right? So we need a statistical way to write all of these things. But not only that, we need to make sure these prices are actually cointegrated. Now, what is cointegration? Well, again, this video will describe it so much better, but I'm also gonna try my best. You see, to trade any mean reversion strategy, we need that price data to be stationary. And what is a stationary? Well, it means that the mean of that price data or data series is not moving. Now, what is a stationary? It means that the mean of the price data or data series is stable. It's not changing. Because right now in this picture, we know the mean is this, but that's because we already have the price data for 2 days, right? So for example, at this point in time, the mean wouldn't exactly have been this value, or at this point in time, it wouldn't exactly have been that, because we would have calculated based on this much data, right? But now that we have all of it, we already know what the mean of it is, right? So if I try to calculate the mean of this data series, is going to change. Now, we don't want it to be like stable 100% to be able to trade. But the thing is, if we try to trade a mean reversion strategy on, let's say, just one asset, we know for sure that it is not going to be stationary. However, we can still trade them if they are cointegrated. And what does cointegration mean? It means that yes, these two price data, even though individually they're not stationary, some kind of combination of their price data, which in this case would be the z-score that we just calculated, that series is stationary. So that's what it means, right? And if that's the case, then we can trade them against each other. But if they're not, we just can't. Now, there are some statistical ways to calculate this, but again, Jesse gives us a utility function which will take care of this. So I'm going to use that one. So let's define a new variable called isCointegrated. And in it, we're going to use the arbitrage utility function. And first we will pass the first price data and then the second. Now let's print this, and it is returning true. So now we know they are co-integrated. Now, if you're curious to know the source code of this, well, here it is. We're using the stats module of Python, and then we use the p-value. And if it is below the cutoff value, we say it is co-integrated, otherwise it's not. Now, I know this sounds confusing, but again, watch that video of Quantopian and hopefully it should make it clearer. Right, now let's move on to Jessie so we can write the code in it so we can run some backtests and see some actual numbers. All right, I'm gonna start by generating a new strategy and I'm gonna call it pairs trading. All right, so now I'm gonna copy this and I will open my cursor editor, which uses AI and is so much smarter and faster to use. And I'm gonna look for this. All right, so this is the generated code. Now, the real challenge for this strategy is that we cannot only define it inside one strategy file, because if I try to run a backtest, you see we have these routes, and right now it is set to BTC USDT. So let's change this to ETH USDC and the time frame to 15 minutes and this one to pairs trading. All right, and the duration is since the beginning of this year until just a few days ago. Now, here's the thing though, we need to trade this for both ETH and Ethereum Classic. So I need to add another trading route. And for this one, I'm gonna choose ETC and the same time frame. But now we need to also pick another strategy. So picking this one alone won't work. So how do we do this? Now I need to generate another strategy and I can pick whichever name I like, but I'm gonna go with pairs trading 2. All right, so I'm also going to open this one. All right, so now we're going to deal with 2 strategy files. Now, I know you guys have some questions like how do we communicate between the 2 strategies? How do we connect them to each other? And I'm gonna take care of the heavy lifting right now. So let's connect these 2 strategies together. So inside my first route, I'm gonna define the before function, and in it, I'm gonna say if the current index is 0, which means it's the beginning of the execution of the strategy, I'm going to initiate 2 variables. And I'm using this special dictionary variable inside Jessie called shared vars. Now, why is it called that? It's called shared vars as in whichever variable that you define in this dictionary is going to be shared among all the trading routes that you have. And I'm calling the first one S1 position and I'm setting it to 0. And then I define another one for the second one. And my shoot long is going to be very simple. I'm gonna say return true if the S1 position value equals 1. That's it. And we're choosing 1 as in a long position. So that means for a short position, we need to do the opposite. So that would be this, right? If the S1 position equals -1. Next, I will take care of closing these positions. And that's going to be using the update position method. And in it, I'm going to say if the value of S1 position equals 0, I'm going to use the self.liquidate method to liquidate the current position for this trading route. Next, I'm going to go to the second strategy, and inside this should long, I'm going to say return if the shared vars S2 position equals 1, and we're going to do the opposite for a short position. And again, be careful with the key here. It needs to be S2 because we're inside the second strategy. And then I'm going to define the update position and do the opposite of what I did for the first strategy. So I'm saying if the S2 position equals 0, that means we need it to be closed. So we will liquidate the current position, right? So next we have the position sizing. So I'm going back to the first route, and inside the goLong method, I'm going to say this. The quantity of my position is going to be the margin 1, which is this value that I'm going to define for the size of the position of the first position. And I'm using this utility function called size to quantity, which will take this as the first parameter, and then the current price, because I want to open the position with a market order, and then I'm setting the trading fees. And then all I need to do is to say self.buy equals quantity and then the current price to open a position using the current price. And for the short position, I'm going to do the opposite. So again, quantity equals this. But instead of self.buy, I'm passing self.sell equals quantity and then the current price. All right, so let's go to the second route and do the same thing here. So I'm going to say quantity equals this, except that instead of margin 1, it needs to be margin 2. and then I will say self.buy equals quantity and then the current price. And then for the go short position, we'll do the same thing. Again, ensure that this one is margin 2. And then instead of self.buy, we have self.sell. Right, I don't know what you're thinking right now, but if it's not clear yet, don't worry, because it's gonna be in a second. But all you need to know is that at this point, these two strategy files are connected to each other. So wherever we change these 4 variables, the S1 position, S2 position, and S1 margin and S2 margin, it's gonna take effect everywhere. But now we need to define the logic of our strategy, the one we just implemented inside this Jupyter notebook, inside our first strategy. So in fact, I'm not going to touch the second strategy file at all anymore. I'm completely done with it. But for the first one, let's begin. All right, so let's go back to the Jupyter notebook. And here we were getting the candles like this using the research module. But if I do it like this during a backtest, there's a good chance I'm going to use data from the future. And we don't want that, right? Because that would produce unrealistic results. So instead, I want to use Jesse's built-in features for fetching the candles, which ensures we don't accidentally cause the look-ahead bias in our strategy. All right, so I'm going to go back to the first strategy and I will define a new property called C1. And in it, I'm going to pass self.getCandles, which is that built-in method for fetching the candles. And again, this one ensures you don't fetch candles from the future. Jesse will take care of it behind the scenes to only give you candles that you had at that point in time. And the first parameter is the exchange, and we're passing the current exchange, and then the symbol. Now this one, it could have simply be ETH USDT, right? But because I wanted to define it dynamically, instead I can use this self.routes, and then I'm selecting the index of 0, and then I'm selecting its symbol. So this way, no matter in backtesting, whichever symbol I choose here, it will work here and I don't have to change anything. So it's better. Now, I'm also doing the same thing for time frame. So I'm passing self.timeframe, which will give it whichever time frame that I pick here. So instead of simply saying 15 minutes, I'm using self.timeframe. And because I want only the closing price, as I showed you earlier in the Jupyter notebooks, I'm selecting all of them, but only the closing prices, which has the index of 2, but I'm also selecting only the last 200 candles. And why is that? Well, in the Jupyter notebook, we only had candles for 2 days, right? But when we are backtesting, let's say we want to backtest it on multiple months. If we give it so much data, the mean of this data series is going to change a lot. And it's not going to even be remotely what we need it to be. So I want to make sure that we cache the pattern of only the most recent data. And that could be the last 2 days, 3 days, whatever. But the point is, it has to be a static number. And I chose 200. You can try any other number and see whichever works best for you. All right, so now let's define another one and call it C2, which is going to be very similar, except we're selecting the second route by using the index 1, and everything else is the rest. So you see, inside my first strategy file, I have access to the data or everything from even the second strategy. So that's why I said I'm not gonna touch the second strategy file at all. All right, now let's define the z-score, right? So first we need the spread, and that is going to be self.c1 minus self.c2. And again, we're selecting from the index of 1 until the end, which again is what I just did inside the Jupyter notebook. And then I'm gonna say z-score equals utils.z-score, and I'm passing the spread. And in the end, I'm returning z-score minus 1, which will give me the last item inside this array. And that's going to be the only one that I care about, because it's not like I want to paint a chart with it, right? All right, so where do we define the logic of the strategy or the rest of it? Now, everything else will happen inside the before function. Now, by the way, in case you didn't know, the before function is the first method inside the strategy cycle of Jesse that will get called. So whichever value that we set inside the before function is going to be accessible inside everything else, inside the shoot long, the go long, the update position, everything. So that's why I'm doing all the decision makings inside this one, and then setting the decisions inside these variables, and then I'm checking for the result of those variables, like for example in here. All right, now let's continue. So once every 24 hours or 1 day, I want to recalculate everything. Like I want to see if the pairs are still co-integrated or things like that. So I'm gonna say this: if self index equals 0, which means in the beginning, or if the remainder of self.index divided by 1 day worth of 1 minute candles. And we can get that by saying 24 multiplied by 60 divided by this number here, right? Now, what is this number? Because we're using the 15 minutes, this is basically 15. But as it was the case with whatever I did here, so instead of hard coding, I was using dynamic values so that if we change something inside the JS's dashboard, it will take effect here, right? So because of that, instead of simply dividing it by 15, I'm going to divide it by this value. I'm using the utility module again and the function time frame to 1 minute. And then I'm passing the current time frame, which is 15 minutes, and it is returning 15. Now I'm saying if the remainder of this division is 0, that means it has passed 24 hours. Then I want to check for cointegration again. Is cointegrated equals utils.arcointegrated, and then I'm passing the first set of price returns, and then I'm passing the second one. And if they are not cointegrated anymore, I want to close all the positions. And I can do that by setting both these values, S1 position and S2 position, to 0. All right, now let's move on. Next, we're going to define the z-score, and we can simply get that using the self.z-score, which we defined in here, right? So let's get that one. Now I'm gonna say if the current position is closed, and we can simply get that using this, and the z-score is below the threshold that we define in here. You remember these two lines? It was 1.2 and minus 1.2. So I'm gonna use that here. So if the z-score is below minus 1.2, then I'm gonna say go long with the first position by simply setting it to 1, and go short the second position by simply setting it to -1. Now, next, I'm gonna say, let's remove this. Next, I'm gonna say, else if it is already long, but the z-score is above 0 now. In other words, so you remember this? We went long here, but once it reaches the mean, we wanna close the position. So I'm gonna say if the z-score is now above 0, set this one to 0 and also this one. All right, so both positions need to be 0 or closed. And next, I'm gonna say if it's a short position and the z-score is below 0, and that would be this case. So if we went short, but the mean is now below the mean, then again, close both positions. And lastly, I'm gonna say else if it is closed, but the z-score is above 1.2, which would be this case, I wanna short the first position and long the second position. All right, now we have the decision making of our strategy. We know when exactly it's going to go long and when it's going to go short. However, we're still missing one variable, and that is the size of the position. And this is really important because the bigger the size of the market cap of an asset, the less volatile it will be. So in our case, we already know that the price of Ethereum will move less than the price of Ethereum Classic. So let's say they are moving exactly at the same time. If only the size of the positions are exactly the same, for example, if we long one of them with $1,000 and short the other one with $1,000, when they move, let's say they both go up, it's still the one with the lower market cap, which would be Ethereum Classic in this case. And that means if it was the long position, we're going to be in profit, but if it was the short position, we will lose money, right? And that's not what we want. So we need to make sure the size of these positions are not exactly the same value, but they are somehow equal in matter of like how much money we would make or lose between them, right? Now, how do we do that? So first, I'm going to define a new function, and I'm going to call it set proper margin per route, right? And I'm going to call this firstly in here and second in here. So again, this is where we opened the first long position and the second short position, and this is where we did the opposite, right? And these two we were just closing an already open position. Now, this is incorrect. I'm gonna remove it. Now to calculate this, I'm gonna use a formula, which again, luckily Jesse provides us. So we're gonna get the alpha, but I'm not gonna use the alpha. So I'm just gonna pass an underline and then the beta, and it's going to equal utils.calculate alpha beta. And this is this formula. So we're using the stats model again, right? And this is the formula. So the x equals add constant, and then we're passing the second returns, and we're using a model to do linear regression, I think. And then that will give us the alpha and the beta, and then we are passing them. I'm not going to go through the exact math behind it. Again, if you want to, just watch that video from Quantopian, which they do explain this better. Now, this is giving us both the alpha and the beta. To calculate the margin, I'm using the current available margin multiplied by 1 divided by 1 plus beta. And for the second margin, or the margin of the second position or the second strategy, I'm using it like this. Now, to be honest with you, I'm not a math wizard myself, and I use ChatGPT heavily for writing this part, but because I did a lot of testing, I know it's actually working. So sorry if I cannot explain this any better. All right, so that's it. Now we have the margin 1, the margin 2, and the values for S1 position and S2 position. And now we're ready to execute our first backtest. So let's go back to Jesse, and we have both the trading routes, ETH, ETC, the 15 minutes time frame. Pairs trading is selected, but the second one also needs to be pairs trading 2. And the duration, make sure the fast mode is off because it actually cannot work with multiple routes yet. So if I try to start it here, I'm gonna get an error. So let's turn this off. And I'm gonna leave the, actually let's turn off the benchmark first and let's run it. All right, so this result isn't right, and I went back and found the issue. The issue is that we are passing the current candles, but as it was the case in here, we later converted the current candles into price returns. So we need to do the same thing in here. So I'm gonna select this and instead return prices to returns and then pass this and this. All right, and I'm also gonna do it here. All right, so again, we are converting the current candles into price returns, and that's the correct format for the calculations that we did with z-score and everything else. All right, so let's go back and run this one more time. There we go. This equity curve looks unbelievably good and is for the last 12 months. The profit was 69%, the max drawdown is -5%, the win rate is 53%, the Sharp is 2.94, and the Calmer is 13.77. Right, so let's go back and turn on the benchmark feature too and run it one more time. So while that's going, I want to quickly remind you guys that I recently added support for Apex Omni, which is a DEX, which means you will keep the custody of your funds and there is no KYC. You just connect your MetaMask wallet and you're good to go. If you want to get started with Apex, please consider using our link, which will give you trading fee discounts, and you'll also be supporting making these videos. All right, so check this out. While the price was going up, we made money. While the price was going down, we made money. When it was in a range, we also made money. So that's why we call this strategy a market neutral strategy, because no matter if it's going up or down or in range, you're gonna make money as long as the bet that these two price assets are co-integrated is true, right? So that's why it's really fantastic. So guys, this result is actually too good to be true. So I'm just gonna buy a Lambo and make videos about how rich I am, all right? See you in the next video. But hold on a second, there's a catch, multiple of them. You see, unlike my other videos or backtests that I run, I actually disable the trading fees in this case. That's why we are not paying any trading fees. And this is really important because it is taking 7,818 trades over a year. That's simply too many trades. And it's not like we own the exchange or are friends with them. We are going to have to pay for trading fees. And we're not even a hedge fund, because hedge funds, and I'm guessing Edward Thorpe too, they paid very little fees because they had special contracts, but we don't. So if we set the trading fee to what it actually would be on Binance Futures and run this one more time, let's disable the benchmark feature. Now the result actually looks awful. So we started by 10,000 and we ended with $343. Now why is this? It's because, again, we're taking too many trades and we are paying just too much in trading fees. We're paying $11,000 in trading fees. Now it actually gets worse. In reality, not only would we have to pay this much trading fees, but we're also going to have slippage. And because in this strategy, at least at the current state of it, we're even counting on trades with very small margin of profit. So that means if there's going to be slippage, which there will be, the results will look even worse than this. So to get the realistic results, we need to set this to a higher number, such as this, or maybe this one. So what does this mean? It means that if you're a hedge fund, you can probably already trade this. if you can get some kind of special contract or trade it on an exchange that has very little fees. But for most of us, that's not the case. So what we can do is to implement as many filters as possible to make sure that we only take the trades that are worth it. Now, the other thing that we can do is to trade only assets that are more volatile. For example, meme coins. We know they are correlated with each other, but they move much more. And that means our trades probably won't have as little profit margin, which would make it worth it for us. I'm going to share the source code of this strategy on a GitHub repository and link to it down in the description. It's going to be your homework to keep doing research and implementing filters to improve the results of this strategy and make it actually production ready. You can also try it on other markets with different trading assets and see if it works there, or preferably with exchanges that have lower trading fees. I would love to see you guys on our Discord and share with me your experience with this strategy and let me know what works for you and what doesn't, so that hopefully we can improve it. If many of you guys want me to make a follow-up video about this strategy, I might do it, so just let me know about it. Now, as always, we're gonna have a giveaway. A random person who likes this video, posts a comment and subscribes to the channel is going to win 1 million bonk token. Alright, let's pick the winner for the previous video. And the winner is Ramesh. Thank you so much for your comment. Please reach out to me so that I can send you your bonk tokens. Thanks for watching, and I'll see you in the next one.